All right, so today we're doing section 5.6. I heard someone say, didn't we already do these? Yes, these are not new vocabulary terms. We're actually spending the first slide reviewing what the vocabulary terms are that you already know. But we're going to look at the triangles that are formed when you have these things and how it affects the different segments you can create, okay? So it goes right along with the congruent triangle stuff we've been talking about. It's really the last normal section in chapter 5. We are doing another set of notes tomorrow, but that's kind of something totally different. So this sort of wraps up the congruent triangle stuff that we've been looking at. Anyone need more time with this guy? Nope. All right, so here are the review. Don't write these down. They should already be in your notes somewhere. But I just quickly want to talk about angle bisector and perpendicular bisector. So an angle bisector is a ray that divides an angle into two congruent angles. So if I start with a big angle and I slice it in half, that's an angle bisector. So we're going to look at those today. We're also going to look at perpendicular bisectors. Now perpendicular bisectors can be a segment, a ray, or a line that's perpendicular. So it's got to make a right angle and it's the same distance from each of the ends. Okay? So again, you don't need these in your notes. You should already have them in your notes. You should be familiar with these terms already. We're just going to look a little bit further at them today. Any questions so far? Here is where the new material starts for today. So again, we're starting with angle bisector. Looks a lot like the last slide. However, now we're looking at what happens when you put a point on the angle bisector. Any point on the angle bisector, no matter how close or far it is the same distance away from the sides of the original angle. Okay, so those segments would be congruent. If I go out to the black point, those segments are congruent. If I go out to the blue point, those segments are congruent. And the reason is it makes congruent triangles, which is why we learn it in this chapter, but really it's sort of its own idea, okay? I like to think of it as like something you could slide back and forth. No matter where you slide this point, it's the same distance to here and here. So go ahead and write this down, draw the diagram. We'll look at what happens when you have the perpendicular bisector, and then we'll get into some examples. So next we'll look at perpendicular bisector. The good news is it's a very similar idea. I still want you to write this one down though. But any point along this perpendicular bisector is now the same distance away from the end points, if I can draw correctly, of that segment that it bisected. And the same reason it's creating those congruent triangles that we've been talking about for weeks now. And whether you slide that point closer or farther, it's still the same distance away from those endpoints. Okay, next we're looking at examples, so you don't need to write them down. I just want you to soak them all in. So the first one, we have an angle bisector. I can tell it's an angle bisector because there's an angle and then two congruent angles created by a ray going down the middle. When you have an angle bisector, any point on that bisector, like point Y, is going to be the same distance away from Z as it is to X. So I'm looking for Y, X. How long is YX? 5.5, it's the same. Good. That's our first type of problem. The second one is a perpendicular bisector. I can tell because I see the right angle and I have a segment. In this case, it's segment AC that's cut into two congruent segments. Any point along that bisector, like point B, is the same distance away from those endpoints. I'm looking for the length of BC. What is it? 13. Now, it's really easy when the only measurement you're given is also the answer, right? It's not always going to be like that, okay? So you have to know, it should be this easy, like you're just picking out one of the numbers and it's congruent to it, but sometimes there are other numbers in the diagram as well. So don't just get in the habit of grabbing the only number that you see and writing it down. You gotta know where to grab it from. Any questions? Okay, here are two examples. They're both angle bisectors. This one's missing the bisector symbol, but we just know they're angle bisectors. Pick one and draw it. I don't care if you do number one or if you do number two. I'll give you a few minutes. Then we'll do them both together. In the first one, you're looking for BD. In the second one, you're looking for KL. So once again, pick one of them, draw it, try to answer it. If you get that one all the way done and you want to do both, go for it. I'm going to give you until about 1:47 to get this done. Number one. Point D is on the angle bisector, so what do I know about BD? BD is what? 15. Awesome. Same idea on number 2. Point L is on an angle bisector. How long is KL? 10. Phenomenal. Questions? So go ahead and draw number 3. But you can do number 4 if you want. I just assumed everyone would do the easy one. So pick one of them. Do it. Number 4 is kind of what I was warning you about during the examples. It's not as easy as just picking the only one number in the diagram. Sometimes, usually, there are more numbers. You got to know where to pick it from. It's equally as easy, I think. You just got to know where to look. Okay? So I'll give you about another minute, maybe 2, and then we'll go over these guys. All right, so those of you that chose number 3, notice that G is a point along the perpendicular bisector. So what's the length of FG? 12. It is 12. Good. Now the one that's a little trickier than just picking out one number. Number 4, S is on the perpendicular bisector. Fun fact, so is Q. See how Q is 20 and 20? That's fun, right? So for S, how am I going to find PS? Yeah, you just look on the other side. So it's from that point to the end point. So if you're going to the end point P from point S, you look to the end point R from that same end point S, okay? So like I said, I don't think it's not hard. You just got to know where you're looking. Any questions on these two? Now, here's where we kick it up a notch. And I just want you to do the work with me. You should have one picture of each type in your examples and also in the vocab. So I think you've got enough diagrams in your notes right now. But I want you to practice writing these equations. So for number 5, point D is on the angle bisector. So what do I know about these two expressions? Yep. They are congruent. They're the same distance. D is the same distance away from C as it is from E. So the segments that are created are equal. So make these equal and solve for your variable. Now I have X's on both sides. These are getting a little trickier. What do I do? You tell me. You either add 10x or subtract 10x. Where's the thoughts from the back? What are? Yeah, you got to undo the positive 10x, so you got to subtract it. You could do minus 9x. You just end up with nothing, and then you'd have to add the 3. It's one extra step, which isn't a big deal. it would still result in a correct answer. Now what? Divide by. Huh? Yeah. What's bothering the x? Negative. It can't be bothering itself. Yeah, you just divide both sides by -1. What's a negative divided by a negative? +3. Good. All right. I am going to hold on. All right. What? Come on, I got to register you guys. All right. We have D on a perpendicular bisector. So what do I know about the distance away from A and C? Congruent, same distance. Equidistant was your big word for today. So 12x equals 96. Divide both sides by 12. X equals 8. Great. Any questions? All right, we do have one more slide of examples, but I'm not going to make you put them in your notes. We're just going to do them out loud for extra practice on these equations. All right. So, F, perpendicular bisector, perpendicular, congruent segments. What do I know about these two guys? They're congruent. This is a two-stepper. Yep, you got to undo the adding and subtracting first. And then you undo the multiplying or dividing. X equals 13. So I wrote the equation. H is the same distance from both. We're already subtracting 8, so to undo that, we have to add 8. Good. So X is what? 43. Good. All right, you didn't have to write those, so we shouldn't have to really wait for anyone. Let's jump. What did we learn about today? Angles. Angle. B, the B word. Bisector. And what other type of bisector? Perpendicular. So I'm going to, not done yet. I'm going to put it all together. Angle and perpendicular bisectors.